hi to everyone. As Simon already said, I will talk about SQL Server Intelligent Query Processing on SQL Server 2019 and 2017. Intelligent Query Processing is just a marketing name for 7 features that are available on SQL 2019, and 3 of them were available already on SQL 2017 under a marketing name Adaptive Query Processing. So let's start. A little bit about me. I'm a senior database developer. I love to performance tune databases and SQL servers. I am a Microsoft certified trainer, co-organizer of SQL Saturday Croatia and past meetup SQL Server User Group Croatia. And here's my contact details. You can find me on LinkedIn, Twitter under Dean Savović. So if you have some questions about SQL Server or about this session or about anything related to SQL Server, please feel free to reach out. So agenda for today are features from Intelligent Query Processing stack. So we will go through all of them. We will talk about a little bit about theory about them and show a demo about each of them. And at the end, we will have some room, I hope, for questions and answers. So the features under the Intelligent Query Processing stack is, as I already said, part of them are already available from SQL 2017 and are called Adaptive Query Processing. Those are adaptive joins, interleaved execution, memory grant feedback, and so on. Some of them on this slide are marked with 2 letters E, meaning that they're only available on Enterprise Edition of SQL Server or Developer Edition, but you cannot use Developer Edition in production. So in production, you can use only Enterprise Edition. So adaptive joins, memory grant feedback, and batch mode on Rowstore are only available in Enterprise Edition of SQL Server. All others are available in standard. So 3 of these features, as I already said, are Enterprise Edition only features. And the thing I want you to remember that 6 out of these 7 features can affect your existing code, positively or negatively. So you can have query regressions, or you can have improvements in your queries because of these features when you migrate to SQL Server 2017 or 2019. An important thing to remember is also if you migrated your databases to SQL Server 2019 and adjusted the database compatibility level to 150, which is the compatibility level of SQL Server 2019, all features are activated by default. And on SQL 2019, OLTP workloads interact significantly with Intelligent Query Processing features. On 2017, they interact by using column store indexes. So basically, I think that you would use column store indexes basically more on data warehouse solutions. So on 2017, the story is different. Let's talk about execution plans and how Intelligent Query Processing affects execution plans of the queries. Very interesting topic. Queries that are affected by Intelligent Query Processing are the queries that use table variables, tables that use user-defined functions, queries that use multi-statement table valued functions, complex queries, and queries that use tables with skewed data distribution. They all can benefit from Intelligent Query Processing, but there can also be some regressions in the behavior of the queries. Issues that are resolved by intelligent query processing are inappropriate operator choice, meaning nested loops versus hash match join or vice versa, and memory grant under or overestimation. Big difference between SQL Server 2016 and prior and 2017 and 2019 are that on SQL 2016 and prior, all planned decisions are made at compile time. So not after the query is compiled, nothing can be changed in the execution plan, in the execution of the query. And once the plan is created, only recompile or memory pressure if the plan is forced out of the plan cache. So nothing other than this can change the execution plan that is in the execution plan cache. On SQL Server 2017, we have 3 improvements. Multi-statement table valued functions interleaved execution, which means that SQL Server will execute the multi-statement table value function in compile time and get the exact number of rows that function will return in the query, and have the exact number of the exact cardinality of that function. This is a big change comparing to 2016 and prior SQL servers, because prior to that, SQL Server has a hard-coded guess of 1 up until SQL 2014 and 100 after SQL 2014. Next, we have adaptive join and memory grant feedback that runs in batch mode. Adaptive join also runs only in batch mode. And these are the ways that SQL Server can, after compiling the execution plan, change the execution plan that is in the cache. So this is really a big thing. And on SQL Server 2019, there are additional adaptive improvements like interleaved execution of table variables, which behave the same as multi-statement table value functions. So SQL executes them and gets the correct cardinality. And memory grant feedback in SQL 2019 now works in row mode also. So in 2017, it worked only in batch mode, so using column store indexes. And we have T-SQL inlining, which is a great feature also. So now it's time to go through each of those features in detail. So first of them is adaptive joins, which works in 2017 and 2019, but only in batch mode. So meaning that we need to have a column store index on the table that is touched by the query. And adaptive join is a new operator you will see in the Management Studio, which can in runtime decide whether it will execute as hash or nested loop join. So adaptive join operator is a logical operator, it's not a physical operator. In runtime, SQL Server decides based on the threshold that is calculated at compile time of the building the execution plan, whether the hash or nested loop join will be used. As I said before, this feature is on by default. You can turn it off by altering the scoped configuration of the database and setting batch mode adaptive joins to off, or by using query hints. This is a good feature that handles oscillations in number of rows that are coming into the adaptive join, meaning that SQL Server at runtime can, if the number of rows is less than threshold, choose to use nested loop join, and if the number of rows coming in this number 1 table is greater than the threshold, SQL Server Query Optimizer will use hash join. So this is how SQL Server handles oscillations with adaptive join operator, and this applies only to select queries. There is obviously some overhead because SQL Server at runtime has to decide whether to use nested loop or hash join, but this overhead is compensated with SQL Server choosing the right operator to do the job. Let's now switch to Management Studio and show this in practice. I will zoom in so you can see what I'm talking about in this demo. We will use wide world importance DW database. Make sure it's in compatibility level of SQL Server 2019. And we will free proc cache. Okay. Let's go into this database. With this statement, I'm just making sure that column store index exists on fact order table because I need it for adaptive join to kick in. Okay. And now let's execute these two queries. These two queries are exactly the same. The only difference is that the predicate for the quantity is 360 in the first query and 361 in the second query. So let's run them together. Let's include actual execution plan. Okay, it's already included. And run this. First query returns 206 rows and the second query returns 0 rows. Let's see the execution plans. You can see here adaptive join operator and here also adaptive join operator. So the first query, let me show you when I hover over the adaptive join. You can see here that adaptive threshold I talked about is 67.89. So if the first table running into the adaptive join has more rows than 67.89 in runtime, remember that, then the operator will transform to hash match as it is here. And in the second query, we can see that adaptive threshold is 6.5. Why it is different than in the first query? Because it's a different query because of the different predicate, and my database is in simple mode of parameterization. It's not enforced. So now SQL Server, because 0 rows are coming into the adaptive join operator, is choosing nested loops. So in runtime, SQL Server chooses nested loops or hash join. If you, for some reason, identify that after migrating to SQL Server 2017 or 2019, if you experience some regressions in your queries, you can easily disable the batch mode adaptive joins by using this hint at query level, or you can disable it on the database level. But I highly recommend that if you determine that some query is slower than before because of this batch mode adaptive joins, you can use this hint to disable the adaptive joins, and now you get the old way of compiling and running the execution plan by SQL Server, and you will not see adaptive join operator, but SQL Server Query Optimizer will choose nested loop or hash join at compile time and use it at runtime. Okay. Next feature is memory grant feedback. It works on 2017 in batch mode only, and in 2019 in row and batch mode. What is memory grant feedback? Well, this is a feature where SQL Server at runtime can modify the memory granted to the query. So if SQL Server determines that too much memory was granted to the query, in the second execution of the same query, SQL Server will decrease the amount of granted memory, and vice versa. If the granted memory was too little, and because of that you had some problems with the query, like spill.mdb or something else, SQL Server at the next execution of the same query, which is fetched from the execution plan, will give this query more memory than it was initially given. So this is again modification of the execution plan in cache. You can also disable it or enable it, and if SQL Server encounters a situation where memory increase, memory decrease fluctuation is going in the loop, you can imagine that this can happen. After about 30 occurrences of this increase and decrease fluctuation, SQL Server will disable memory grant feedback for this statement. Let's see this in the demo. Okay, let's include actual execution plan. The first part is the same in all the scripts. Make sure that it's in 2019 ability level. And now we will execute this query and take a look at the properties. So let's run this. Okay, it's taking more time than... Okay. So in the execution plan, we see the exclamation mark with the select operator. Let's click on it, hover it, and you can see that the query had to wait 13 seconds for memory grant during execution. Okay, this is why we waited for the query to execute. But the more important thing that I'm talking about here is the query memory grant detected excessive grant, which may impact the reliability. Grant size initial 23 megabytes, final the same, and used only 120 kilobytes. So this is something that memory grant feedback should correct. Let's take a look at the properties window of the select operator, and under memory grant info you can see here that is memory grant feedback adjusted? No, this is the first execution, so there is nothing to adjust because the query is not yet in the execution plan cache. Let's run this query again. Okay. Again, we have an exclamation mark. Let's see what it says now. It says the same message. Let's take a look at the memory grant info. It's still saying the first execution. There is something wrong with my plan cache. Let's run it again. Okay, now we don't have exclamation mark on the select statement, and memory grant info says, is memory grant feedback adjusted? Yes, adjusting. Now if I execute it a few more times, this message would change to yes, stable. Okay. Let's go to the next feature, and next feature is interleaved execution. Interleaved execution is a feature that applies to multi-statement table valued functions, which had a fixed cardinality of 100 from SQL Server 2014, and before that the fixed cardinality was 1. And this could lead to numerous problems when you had multi-statement table valued functions that returns hundreds of thousands or millions of rows. SQL Server 2017 and 2019, when encounters a multi-statement table valued function, pauses the optimization at compile time, executes the function, captures the accurate cardinality, and then resumes the optimization. And at runtime, because the function was executed at compile time, it doesn't have to execute it again. So he only executes it once, and this is during the compilation of the execution plan. This only applies to select queries, and as always, you can turn it on and off. Let's see this in a demo. So this is the demo. Let's clear the cache. Okay. This is our function. It's a very simple function that takes start and end dates as parameters and returns a table, and we insert some rows in that table from the fact order table where order date key is between start and end. So very simple, but multi-statement table value function. Okay, so this is not an inline function. And now let's take a look how this behaves under compatibility level 150. So this is SQL 2019. I forgot to include the actual execution plan. Sorry about that. And in the execution plan, we have an estimate, the number of rows of 5,281, and actual number of rows is exactly the same. This is what we expected because of what I told you about this feature. And we can disable this with a hint or by setting the compatibility level of the database to compatibility prior to 2017 SQL Server. I'm putting this database into compatibility level of SQL 2016. And now if I run this, we get an estimate of 100, and actual is the same, of course, because it is the same function and we are using the same set of parameters, as you can see here. Okay, when could you have problems with these features? Well, you could have problems when you rely on the old cardinality estimator. So if you rely that for your multi-statement table value function, you will get 100. Even the function is returning more rows than that, then you could have regressions in after migration to SQL 2017 or 2019. Those three features were the features of the SQL that were available already on SQL 2017. Now we will go through the features that are available on 2019 only. So the first one is table variable deferred compilation. The story is the same as with TVFs. The SQL Server pauses the optimization of the execution plan, executes the table variable, and gets the actual row count. Before that, it was a one row guess. So on SQL 2017 and prior. This doesn't mean that table variables get column statistics, and this doesn't increase recompilation frequency. And what happens with the variations in table variable cardinality? Well, this is the same as with any other predicate. You are prone to parameter sniffing, which could sometimes be a problem and sometimes not. Let's see this in a demo. Okay. Let's include actual execution plan. We have a table variable named foo, and order key is the only field in that table. We are filling in the table variable with rows from the fact order table with the same parameters we use for the multi-statement table value function. And then we are selecting from fact order and joining this foo table variable by order key. Let's see how this behaves on SQL 2019. So we get the execution plan, and in the execution plan you can see that estimate is spot on, 5281, and actual is 5281. Sorry, this one. So this is because SQL executed the table variable and got the exact number of rows from that table variable. If we lower the compatibility level to SQL Server 2017, we will get different results. So now I'm executing the same set of statements I executed before on SQL 2019. The only difference is the compatibility level, which is now 140. So SQL 2017. And let's take a look at the estimates now. It's fixed guess of 1. And the actual number is, of course, 5281. Next feature, a really good one, is Scalar UDF Inlining, available on SQL 2019. So what is Scalar UDF Inlining? So it applies obviously to Scalar user-defined functions. And the SQL Server Query Optimizer is now able to transform these user-defined functions into relational expressions. This is set-oriented, and it is able to run in parallel, which was not the case in the SQL 2017 and prior. Whenever you had the UDF in the query, this query couldn't run in parallel. It was only able to run in serial mode. And in Management Studio, when you took a look at this query, it lacked of costing. This was a black box to SQL Server. and to us when looking to the execution plan in Management Studio. And let's see this in action. Let's see a demo. Okay, let's do the same thing as we always do. Okay, and now we have a Scalar function named total price, which takes a customer key as input parameter, and from fact order for this customer calculates the total including tax. It calculates the sum of that, puts that in the variable total price, and returns total price. So let's create this function. Okay, and now let's run the first query, which is on SQL Server 2019. And let's set statistics time to on. So this query runs relatively fast. It executed in 2 seconds. And the execution plan, we can see that SQL Server unwrapped that Scalar function. It is here. It's getting data from the order table. Aggregation we can see here, and so on. And when we disable T-SQL Scalar UDF Inlining, so we are still on SQL 2019, but we have disabled UDF Inlining. Let's run this query. And this query just, it will not execute even in the satisfactory number of seconds. I will not wait for the query to execute because it will run very, very slow. Let's take a look at the estimated execution plan. And you can see here that UDF is in the different part of the execution plan. You don't even have it in the, it's a black box to SQL Server. If we display the estimated execution plan of both queries, you will see that the query that doesn't allow SQL UDF inlining is cheaper by Management Studio, but this is only the estimate, of course, and this one is more expensive, which is a total lie. Let's go to the next feature. Next feature is batch mode on Rowstore. So this works only on SQL 2019 and on Enterprise Edition of SQL Server. It enables you to run batch mode queries without column store indexes. So what does even batch mode means? SQL Server can execute queries in row mode or batch mode. Row mode is the old way, available from forever, and it means that the first operator, for example select, asks for one row from the next operator, and this operator asks the next operator for one row, and it goes to the index seek or index scan or table scan operator, which then retrieves one row and gives it back to the operator that asked for that row. In batch mode, the procedure is similar, but operator is not asking for one row, but for batch of rows. How many rows will be in the one batch depends on the size of the row. So what are the scenarios which can benefit from this? These are analytical queries on OLTP databases, joins and aggregates, scenarios in queries which are CPU bound, and if you cannot afford to create a column store index on your OLTP database because it is too much overhead for you and for your database. Operators that can be run in batch mode are hash join, hash aggregates, sorts, window aggregates, filters, concatenations, and compute scalar. And there are some limitations, like only disk-based tables and indexes can be used. You cannot use in-memory tables and expect to be run in batch mode, and you cannot use LOBs, sparse, column sets, and XML. So let's see this in a demo. Let's put the database into compatibility level SQL Server 2019. Let's go into wide world importance DW. Let's drop the column store index on the fact order table to show that batch mode works without column store indexes on 2019. And we are running the same query. These two are completely the same. The first one has a hint allow batch mode, which is not needed, but let's have it here. And this allow batch mode disallows the batch mode from the second query. Let's execute this with actual execution plan. And let's take a look. So first query returns 100 rows and second returns 100 rows also because they are the same. First query that used batch mode ran in 163 milliseconds and the second one in 348. So the first one was quicker. And if you take a look at the operators, you can see that estimated execution plan and actual execution plan mode is batch. And on the second query, it is row. The difference in the execution time between these two queries is not significant, but when you're talking about hundreds of thousands or millions of rows that have to be processed by the query, then the difference will be much higher. And then we have approximate query processing feature, which introduces the in SQL Server 2019 approx count distinct function that allows you to return to the client approximate number of rows, distinct rows, and it guarantees up to a 2% error rate within a 97% probability. The most important difference between count distinct and approx count distinct is that approx count distinct will use much less memory to do the same job, and it will run faster, of course, but you will not get the exact number of rows. So let's see this in a demo. Okay, let's use AdventureWorks wide world importance DW. And we are counting order keys on fact order. Okay, you see that the result is different. This is an approximative result. This is the exact number of of rows, and I didn't include actual execution plan. Sorry for that. I will do this again. And in the execution plan, you can see that select statement had a memory grant of almost 0. And sorry, almost 0. And this one had 23 megabytes. This one. So it's much higher memory usage when you use count distinct, in contrast to using approx count distinct. Okay, this is all I wanted to say.